today we are going to learn what embedded system in general is. And so, what we do is we go to the definition of embedded system. So, very simple way to go to Wikipedia and just do some searching, some reading and so on. So, I have just taken screenshot of the Wikipedia web page. You will also visit that and read that in detail, but I have copied some part of that, and this is what it says. The embedded system is a computer system with a dedicated function within a larger mechanical or electrical system, often with real time computing constants. So, what we understand now is basically it is a computerized system. Some kind of computer will be there inside, maybe a small, maybe bigger, whatever. Typically it will be a smaller one because it has a dedicated function, typically dedicated, not a very general purpose, with larger mechanical or electrical system. So, it will not be a standalone, but it will have some other systems, so that the overall system will be a different kind of system in which this computing system will be there, and often with real time constants. Like a camera, you have to have a flash going on as soon as you click the take photo button, like that. It is embedded as part of complete device, often including hardware and mechanical parts. By contrast, a general purpose computer such as PC is designed to be flexible and to meet a wide range of end user needs. So, there is a clear bifurcation between PC and embedded system. Embedded system typically is small, having some sort of intelligence and also dedicated. But PC, it is typically a large system, lot of RAM, not dedicated to a single functionality. You can do anything with that and so on. So, in general you can say that it is a computer system with larger definition, larger mechanical and electrical system. And the last bullet is embedded system control many devices in common use today. So, if you look at the common devices we have, I am going to show you some examples later on. If you look at any embedded system device, you will find that the processor is a key part in that. For example, a mouse is an embedded system. This pen is also an embedded system because it has some kind of intelligence, right. So, having intelligence, if you want to do if you want to have an intelligence in a device, you must have a processor and associated software. This is common understanding. So, that is the heart of the embedded system. So, we will be learning two kinds of processors in this semester. One is PIC processor in short, and the other one is LPC 2148, that is ARM 7 based processor, but that is in deep. So, we will be going from fundamentals like architecture up to programming and building some systems based on that. That is the ultimate aim. So, we should have a hands on experience of using all these things. This is the purpose. If you read the second bullet, we will see it says that the key characteristics is dedicated to handle a particular task. Since the embedded system is dedicated to specific tasks, design engineers can optimize it to reduce the size and cost of the product and increase the reliability and performance. Some embedded systems are mass produced, benefiting from economies of scale. So, we all know many things about embedded system in general because they are around us. Some of the examples I am going to show you now, but till now we understand that embedded system is a system in which there is a processor in general, and it is a dedicated. This is the remaining part you are advised to read from the Wikipedia site. So, you will do that, right. So, consumer electronics, if you look at that field, you will find that there are many devices around us, like this projector. It is also an embedded system because it is intelligent, and washing machine, all consumer electronics, televisions, every device around us is having a processor, right. What is the middle one? Coffee vending machine, and this everybody knows, last one, It's a gaming console, so everybody knows that. So there are lots of consumer electronic devices which we categorize as embedded systems. Then if we go to actual product design, somebody has to design these kinds of things. So for designing also people use embedded systems, right. So the picture shows, the first picture shows that we have some ready-made module, and that module is a small embedded system which is used to develop one more embedded system and so on. The second is also is a popular Arduino board. If you are new to Arduino, go to Google and Google that Arduino. The third one is what is that? What is that? Oh, it's an oscilloscope or logic analyzer, whatever you call. So that logic analyzer is again an intelligent device, and it is having a dedicated function of doing that logic analysis and showing the result accordingly. The next one is, what is that? The corner one, left bottom corner. It's a spectrum analyzer. That's also a somewhat larger dedicated system. The next one is, the next one seems to be a pick and place device. It's a pick and place device, right. And on the left hand side of that picture you see some reels. So these reels contain components, tiny components, surface mount components, and those components are taken and they are picked up and then placed. This is a very simple semi-automatic kind of machine, but you can see on YouTube lot of machines which are fully automatic. If you just type the keyword on YouTube, that component assembly machine, then you will get lots of videos, and you are advised to see that. The last one is again a general purpose system which can be used for developing newer embedded system. So embedded systems are used in product design also. Then in audio video there are lots of applications. What is the first one? iPod, everybody knows almost. Then cameras are intelligent nowadays. The next one is video camera. The next one is, what is that? Sound? Equalizer. She says equalizer. Anybody else? This is a mixer. It's a mixer. It has equalizer. It has level adjuster. Everything. Stereo to mono, and so many functions. The next one is general purpose music system. In earlier days, music systems did not have any processor, but nowadays everything is digitized, and therefore all these are embedded systems. The last one is, what is that? It's a microphone. Now microphone doesn't seem to be embedded system. Microphone is simple microphone. It's an analog device. How come it has a processor in that? Right. If you look at the bottom of that picture, there is a USB cable. There is a USB cable, and that goes to the PC. So if the microphone has to output USB compatible data, then it has to have some processor, right? So this is the reason. This microphone is from, I think, Samsung or something like that. Samsung. Anyway, but what we understand, that microphones are also becoming more and more intelligent, right? So whatever we did not think of can be an embedded system, they are becoming embedded systems nowadays, right? So audio video, there are lots of, you can find out lots of other examples also. Then in communication, still there are lots of applications. What is the first one? It's a switch, hub or switch, whatever you call. For networking we require. The next one is modem. Next one is modem. We have modem in our houses. The next one is USB pen drive. That is also a embedded system. Why it is embedded system? Does it have a processor? Yes or no? Pen drive, does it have processor? Does it have memory or processor? It has memory, but does it have a processor? He says yes. What about you? She now says that it can be. So, what is the by and large opinion? It has to be some system, because memory, if you look at your old days where you learnt memory, address bus, data bus and so on, a lot of things you learned, memory cycle, read cycle, write cycle, so many things you learned. Now, typically address bus will be 16 bit or 20 bit, nowadays 16 GB or whatever. So, the address bus would be quite big, correct? Na? Now, do we have those many lines on USB? No, we do not have those many lines, correct. Serially 4 lines are there, out of which 2 lines are for VCC ground and 2 more lines for signal, correct. Na? So, all this data has to be serialized. That is why we call it as a universal serial bus, correct. And there should be a processor which will read the memory content and send it to the PC serially, following appropriate USB bus protocol. Everybody getting it? So, obviously, there must be a processor. So, obviously, pen drive is an embedded system. The next one is GPS. So, you fit GPS receivers inside a car and you can navigate. The next one is telephone. Telephone does not seem to be embedded system, but why it is embedded system? Because nowadays it has displays, keyboards, storage and so on. So, it has to have a processor, and that processor has to do some dedicated functionality. Therefore, it is an embedded system. The next one is camera. So, why camera is an embedded device, embedded system? Cameras nowadays are intelligent because they can focus on a particular object and they can track an object and so on. They can enable infrared vision whenever it is required and so on. So, they are intelligent. The next one is automotive industry. Lots of things are automated, and you do not fit a very big supercomputer inside a car. We fit tiny intelligent modules at various places, and therefore, they are intelligent systems and they are communicating with each other with appropriate software. So, if we learn embedded systems in appropriate way, we have lot of chances in automotive industry, because it is a big consumer of embedded systems. In the right corner, what you see is pressure sensor, tire pressure sensor, and the right bottom is, everybody knows, it is a electronic lock, right. This is about automotive. Then in computing field, lots of applications again. What is the first one? Hard disk. Is hard disk an embedded system? Yes. Does it do a dedicated work? Yes, it has work of only storing the things and supplying the data whenever it is asked by the CPU. This is the only job. And does it have a processor? Does hard disk have a processor? Yes or no? Right. To communicate with the processor. It means whatever processor wants to say, wants to tell the hard disk that I want this data, then it has to be understood, correct? Na? And the data is stored in a particular way, and that particular way also has to be understood. So, therefore, the processor must be there, right. If you open the hard disk, you will find a printed circuit board having a processor. We call it as a hard disk controller. We generally call it as a hard disk controller, but it is a kind of processor which understands both the way in which the requirement is coming from the processor, main processor, CPU, like Pentium or whatever you call, and it also knows how the data is stored on all the platters. Correct? This is very similar to a person sitting in front of the door of a godown. The way in which the material is stored in the godown is known to that person, but he also knows the language in which the main boss is going to ask him, I want this particular box. Everybody understanding. So, hard disk is a embedded system. The SD card, again a smaller version of hard disk, not mechanical, but non-moving parts. So, this is a flash memory plus processor and so on. The next one is a kind of small board which does some computing, maybe for whatever work it can be used, but it's a kind of computing it does, maybe a protocol conversion or whatever. The next one is the keyboard. Everybody knows that. Why keyboard should have keyboard can be called as a embedded system? It has a dedicated function of accepting keystrokes, and it is having a processor. Does it have a processor? Yes. Why? ASCII codes, right. If you look at the number of keys, typically 104 keys will be there, but you do not find 104 cables or wires coming from the keyboard going to a PC. If you imagine such kind of thing, in fact, we cannot imagine such kind of thing nowadays, that 104 wires plus supply and ground coming from the keyboard to PC. Right. The next one is a small board which has an Ethernet connectivity. So, you can use such kind of boards for developing products which have Ethernet connectivity. The last one is a BeagleBone, which is an embedded Linux platform. We will be doing experiments on actually BeagleBone, this board next semester, because we have a embedded Linux course next time. But this slide tells us that in computing area there are lots of embedded systems being used, right. If you think of any innovative design, you can implement that using embedded system, and typically we would like to do some innovative things by nature, and lots of opportunities are there if you are sound in embedded systems, if you like embedded system, if you are creative in that. Right? It is not only programming and connecting the processor, assembling the circuit, but coming out with newer ideas which will lead to some interesting product, innovative product, right. Then in actual product design, overall product design, there are lots of embedded systems like enclosure design and so on. So, you can have like 3D printers, you can do fast prototyping. 3D printer will have again a processor, and it is a dedicated job of a printing, that is all. Then in industrial automation, we can use lots of embedded systems as building blocks, and they can be connected together to build a bigger industrial automation system. Right. This is about various applications, and by going through these slides we understand that there are lots of applications of embedded systems. Now, we turn our attention to various companies who work in this area, so that we come to know probably where I will be going or where I can think of going, and what kind of work they are doing and what kind of work is suitable for me, and so on. So, Sasken is one of the companies. I have taken only a few examples, but you can find lots of examples, lots of company names. These are some of the core companies: Sasken, then Tata Elxsi. They are working in actual core electronic design. then KPIT Cummins and so on. So, lots of other companies are there which are there in embedded systems. In fact, you can find out, you can prepare a document of who are the companies who are working on core electronic embedded system designs and prepare a document out of that, right. Fine. So, till now what we did is we learnt what embedded system is. In general, we understood that embedded system is something that is having a dedicated functionality and typically a small processor in that, right. Now, we turn our attention to what this course in general is, and so it will cover basics of PIC microcontroller and its programming. This programming I would like to limit to assembly programming, brief assembly programming, and if time allows we will go to C programming. Then the topics will include ARM based processor and its programming, then fundamentals of operating system, then internals of real time operating system, application programming using this RTOS, and the basics of ARM 9 architecture. This will be the overall coverage of the course. So, if you look at, there are 4 distinct parts. One is the PIC microcontroller part, the other one is ARM microcontroller part, the third one is operating system part, and the fourth one is ARM 9 introduction part, right. Fine. So, what do we need to understand the whole thing? We need to have some background. So, this background is 8-bit processor, microcontroller architecture, then C programming. If you are not thorough in C programming, you are advised to go through C programming yourself and recap the fundamentals like data structures, then pointers and so on. Because especially in the RTOS topic, we will be actually jumping into the source code of the RTOS. So, it is necessary that you learn C programming thoroughly, and general electronic circuit design is what is expected. So, this is the aim of the whole course. It means we need to understand PIC architecture, we need to understand ARM based architecture, the motivation behind why people went for ARM based architecture, then C programs for various peripherals, RTOS basics, programming, and fundamentals of ARM 9. Right. The assessment will be as usual, like 10% of the evaluation will be based on assignments, quiz, mini projects. The quizzes will be mostly online as far as possible. And I am planning to have a small mini project for this, so that something will be done at the end of the semester. You will have some working small model, and then 2 semester examinations, SE1, SE2, having 20% of each weightage. First semester examination SE1 will be on module 1 and 2, the next one is on module 3 and 4. So, module 1 is PIC microcontroller, module 2 is ARM architecture. So, SE1 will be, first examination will be based on PIC and fundamentals of ARM. The second will be peripherals, ARM peripherals, programming and introduction to RTOS, right. And the last examination, we call it as a end semester examination, which will have 50% weightage, and that will be based on the all syllabus, but the weightage will be 20% on module 1, 2 and 3, 4 respectively, and 60% weightage will be on the last 2 modules. Right. Right. So, this is a small activity we will do now. how do we decide if a given system is an embedded system or not? Which questions we will ask ourselves? Can we list those questions? Just make a small list of questions which we will ask ourselves, so that we will be able to know that yes, this is embedded system. Right. The first question that we ask ourselves is it having a dedicated functionality? Right. Now, there can be some applications are there where the dedicated functionality is clearly seen, like a mouse, but there are some systems where the line between dedicated or non-dedicated is slightly becoming blurred. For example, of a mobile phone has a dedicated functionality of taking a call, helping us to do messages and so on, but nowadays they are more so powerful that they can help us in creating a document and what not, right. So, that line is blurred, but by and large we can decide that this is having a by and large dedicated functionality. This is the first question. The next question is that real time constraint. Does it have any real time constraint? Right. Any other important question? Processor. It must have a processor as far as possible, right. We do not call a non processor based system as embedded system, right. So, first question is dedicated functionality is there or not. Second question is whether the processor is there or not, and the third question he said that real time constraints are there or not, right. So, such questions we can ask and then we can decide whether it is an embedded system or not, right. The next activity is take any example of embedded system of your choice and prepare a functional block diagram, and then just prepare a document out of that. Yesterday we did some exercise based on that, we can extend that later on, and there is a homework that you will do. You will visit the various websites of various companies which produce embedded products, go through them and understand the inputs, outputs, various control, functionality, etc. Whatever you like to do, you can start thinking. Then you can find out the literal words, literal meanings of words embedded and system from dictionary. When we say embedded and system, we must know the literal meaning of embedded, literal meaning of system as in dictionary. So, go through any dictionary website and find out the meaning of word embedded and the other word system. And we will prepare a report in LaTeX on homework, whatever work is given, and this class activity, small document we will prepare. For that we need to understand what is LaTeX. Yesterday I told you to read about LaTeX, right. Fine. So, what we did till now, if you go through that, we today took an overview of embedded system. We learnt about what the course is about, and at the end of the semester, I feel that you will be comfortable with PIC processor to some extent, ARM processor, you will be able to do C programming, you will be able to handle hardware and do programming of that hardware with whatever logic you want to use, and you will also be comfortable with RTOS. You will know internals of the RTOS, and you will be able to write some applications based on RTOS. This is the ultimate aim. right. Fine. So, next time what we will be doing is we will start with the PIC microcontroller and start with the architecture of PIC microcontroller. And when we try to learn PIC microcontroller architecture, we need to understand why PIC microcontroller architecture is important to us, because we have been studying 8051, 8085 probably and some other architectures. So, there must be some motivation in learning PIC microcontroller. What is special in that, right? So, we will try to learn that the motivation and then try to go in the internals of the architecture.